Statistics, as you know, is a very important topic, and this has applications in several areas, and I am going to give some examples. So to start with the accounting. Now one example of application of statistics in accounting is use of sampling methods for audit. So as you know, when auditors come and they have so many things to go into and they have limited time, what they do is obviously they cannot go into each and every detail, so they go for sampling and they make use of scientific sampling methods based on statistical background and make use of them in doing effective audits. Another area is economics. So most of the planning, whether it is for a business or for a government, is based on the forecasts, some kind of forecast about future. So government, for example, is involved in forecast of so many different data points like what will be the job growth going forward, how the economy is going to do, and most of the forecasts are very useful for businesses because if they know that economy is going to improve in the next few quarters, they can ramp up their manufacturing, they can produce more goods because there will be more demand. Similarly, if the forecast doesn't look that good, if they get a forecast where they think economy is going to go down, so obviously again manufacturers or businesses can use that information and use that to adjust their manufacturing, maybe cut down on the workforce so that they can cut down on expenses, or they may be able to close some plants, otherwise they will be producing extra goods and services which nobody is going to use. So forecasting is very important for future planning, and again there are so many statistical methods and statistical procedures that are very useful in coming out with good forecasts. Another application is in marketing, and one important area in marketing is marketing research. So from time to time marketing people get involved in try and understand what consumers want or what a customer want, what are their needs, and they may conduct interviews, they may conduct maybe surveys and analyze that data and use that for the benefit of the business. So that's a very important activity. Another application of statistical methods is in production. In fact, in production it is used a lot. So one example I will give is quality control charts. So quality control charts basically have three lines, two dotted lines and one solid line in the middle. The first dotted line is called upper control limit. Lower dotted line is called lower control limit, and the central line is called central line. So in production, many times if you go to a good plant, you may see that they have these kind of control charts posted near the machines, and from time to time they take small samples, do some measurements and plot those data points on these control charts. So over a period of time, like on the x-axis you always have time, maybe this could be the first data point, next data point and so on. And the idea is as long as these data points remain within control limits, that means the process is working under control or everything is under control. But at any point, if there is a data point which goes outside the control limits, that is an indication that at that point the process has gone out of control. So many times those processes will be stopped, the machine will be stopped by the operator, and they will take some corrective action such that again that dimension or whatever quality characteristic they are monitoring can go back into the control limits. So this is very useful application of statistical methods in production. It helps in predicting or monitoring a process and taking action when needed. Because statistical methods have application in so many different areas, and in fact more or less every department obviously collects some kind of data. So before we can do anything, else we need to understand that data can be of different types. Generally it is divided into or categorized into 4 different categories. So it is important to understand what type of data we are looking into, because for different type of data, different statistical methods may be applicable. It's not that we can use same statistical method and apply it everywhere. So there is a saying that if the only tool you have is hammer, then every problem looks like a nail. We cannot solve every problem by same tool. We need to understand that different tools can be used more effectively in different situations. So that's why, to start with, it is important to understand what type of data we have. Is it a nominal type of data? Or nominal is just a name. Name of students in a class is nominal data because they are just names. Similarly, name of cities in a state is nominal data, or name of countries, or name of rivers, name of trees, animals. So all the names are basically, they represent nominal type of data, and they have a lot of limitations. Obviously you cannot do much with them. You cannot like add names or divide them or multiply them, because they are just representing something in a text form. But they can also be numbers like student IDs. So student ID can be number, but it is only for identification purpose. Not much can be done with nominal data. Now ordinal has all the properties of nominal. It can also be represented by name and so on. The key thing is that there is an order. So the word ordinal is made from order. This order could be increasing order or decreasing order. For example, students in a university, they may be freshmen, they may be sophomore or junior or a senior. So when we had data like that, where we know that whether or not a student is a freshman or a sophomore or junior or senior, so this type of data will be ordinal data. Similarly, ranking could be ordinal data, like somebody comes first, somebody comes second, third, and so on. So that is also ordinal data. The next type of data is interval. Now interval type of data has all the properties of the ordinal or the previous, but it has something more, and that something more is that the interval between two numbers makes some sense. So difference between two numbers makes sense. For example, temperature. Let's say in January on a given day, temperature was 30 degrees and next day it was 15 degrees. So we can easily take a difference and say that the second day is colder by 15 degrees. So that difference makes sense. So temperature is interval type of data. Next is ratio, and ratio has all the properties of interval, but also something more. And something more is that ratio of two numbers makes sense. For example, if you take age, so let's say a father is aged 40 years and a child is 10 years. So we can always take a ratio 40 by 10, which is 4, and say that father is 4 times older than the son. So because the ratio makes sense, age is a ratio type of variable. In fact, there are so many variables of ratio type. You could have height, weight, length, speed, distance, time, and so on. So there are a lot of variables that fall under this category. Now sometimes there could be confusion between when a variable is interval and when it is ratio. And for that I will suggest a very simple question that you should ask. Does 0 mean anything? If your answer is something, that 0 means something, then it is interval type. If it means nothing, then it is ratio type. For temperature, we ask this question, does 0 mean anything? So does 0 temperature mean anything? So 0 temperature does not mean nothing, because 0 means it is very cold. So it does mean something. So that's why temperature is interval type. Now if you take another example, let's say profits. So if you ask the question, does zero profit mean anything. So if they have made zero profit, obviously they have made nothing. It doesn't mean anything. So that means profit is ratio type of variable. So qualitative data is very subjective. For example, honesty. You cannot get a measuring instrument for honesty. Like you cannot, just like for weight, we have weight balance, or for measuring length, we have instruments. For honesty, there is no instrument. We cannot measure something and say this is like 99.2 or 53.5. Similarly, beauty. So again, beauty is difficult to measure. We cannot measure and say that a particular person is 79.5 beautiful and so on, because it is very subjective. Somebody may find something very, very beautiful, whereas some other person may not find, or may not find that particular thing very attractive. So it is very, very subjective and very difficult to put into numbers. Now quantitative, as the name indicates, is more quantitative, but this also can be classified into two: discrete and continuous. Discrete variables, for example, like number of people or customers entering Walmart between say 9 and 10. This can take values like 0, nobody enters between 9 and 10, or one customer or one person, 2, 3, and so on. So this variable takes only these values. It can take values like 0, 1, 2, 3. It cannot be negative. You cannot have like negative number of people entering Walmart between certain time period. So minimum you can have is 0, and then it goes into increments of 1, like 1, 2, 3, and so on. You cannot have a situation where 1.75 customers walked into Walmart between 9 and 10. So that's not possible. So this type of data is called discrete data. And then continuous data, again you have so many variables, like you have, so let me take example of speed, where you have data in miles per hour. If you look closely, between 60 miles per hour and 61 miles per hour, how many values can exist? So initially it may look only one value, but if you have a measuring instrument which can measure up to 1 decimal, then you could get values like 60, 60.1, 60.2, and so on. If you have a measuring instrument which can measure up to second decimal, you could have values like 60.01, 60.02, and you can have hundreds of values. Similarly, you can, depending on how accurate your measuring instrument is, you can get up to third decimal and so on. So theoretically, between any two numbers, you can have infinite values. So that is one property of continuous type of variable, that between two numbers, theoretically you could get infinite number of values. Now cross-sectional data is approximately taken at same time period. So for example, if I take attendance in a class exactly around 10 o'clock, and if 30 students are present, so that is cross-sectional data. But if I take attendance not only in one class but several classes spread over the semester, then I will have what is called time series data. I have data over several time periods, that is called time series data. But data collected more or less at same point in time is called cross-sectional data. So far we are just trying to understand in how many different categories data can be classified and what are the sources. So two major sources are experimental data and observational. In experimental data, we are trying to collect data through some kind of experiments. So let's say a car company is trying two different types of fuels, and they run three different engines of same type, and they get these mileages. In this experiment, it looks like fuel A is doing better or giving better performance than fuel B. So this is example of experimental data. where we are trying to change something, and what we have changed? We have changed from fuel A, we have changed it to fuel B, and then we are seeing what is the effect. In observational data, we don't change anything, we just observe. So maybe you are standing at the gate of Walmart, and then you want to understand how many customers walk into Walmart every different hour, like between 10 and 11, 11 and 12, 12 and 1, and so on. So there basically you are observing and taking the data based on what you observe. Or maybe a policeman is standing near a freeway and observes at what speed the cars are going on that freeway. So again, that is observational data. The policeman is not trying to change anything and then take measurements and see its effect. One thing to remember is the word data is always used in plural. We always say data are, not data is. And when we collect data, we have to take into account three things. One is time, like how much time we have, and obviously time is very important. For example, let's say a political party wants to understand what percentage of votes their candidate is going to get in the next election. So time is important. If the elections are like only 2 months away, and if a consulting company comes with the data, a lot of good analysis, and comes with the result after 3 months, that becomes of no use. Time is very important. It has to be collected in timely manner, analyzed in timely manner. But cost is also important. Theoretically, we can measure each and everything, but more data you get, more expensive it is going to become. So one has to always balance time and cost. Another important thing is quality. So quality of data is paramount, and it's the most important thing. If we are applying statistical methods to data which is not of good quality, then obviously it could give misleading results. So there is a term called GIGO, garbage in and garbage out. So if the data quality is not good, any amount of even very sophisticated statistical methods applied is not going to save anything. It is going to only lead to some kind of misleading outcome if data quality is not good. So descriptive word is made from describe. Descriptive statistics methods are used for describing the data. So most of the times we try to summarize data when you have a lot of data into tables, or sometimes we do graphical summary and also numerical summaries. So descriptive statistics, so in these three different ways we can describe data or summarize data. And statistical inference is basically taking inference or some kind of conclusion from the data. So if, let me make a small flow chart. So in statistics what we do is we have a population of interest, and because of time and cost we don't have enough time or enough money to get data from each and every element in the population. We take a sample. So population could be of people, or it could be of things, it could be population of cars or some machines and so on, in which a study is interested, and from the population we take a small sample. But this sample is not any sample. This sample has to be representative. It has to represent the population. For example, if I want to predict who will be the next US president, and if I take a sample of 3000 people all living in University of Massachusetts Dartmouth, so obviously that may not be a representative. That sample has to be scattered throughout US to be more representative. Now one more thing I would like to point out is like how much sample to take. So that depends on the population, whether the population is homogeneous or heterogeneous. It depends on that. So if the population is homogeneous, for example, a small sample is good enough, but for heterogeneous we go for large samples. So one example of homogeneous population is, let's say you go for a blood test and a nurse has to take blood from your body to find out what blood group you belong to. To do that, 1 or 2 drops of blood is more than enough. That nurse need not take out all the blood from our body to figure out which blood group you belong to, because blood in our body is very homogeneous. So a small sample will do. Similarly, if the population is heterogeneous, means it has lot of variation, obviously we have to go for large sample. So assuming from the sample we can get good data, then we do analysis, and then we have the result. These results are then applied back to the population, not sample. We do not apply these results to sample, we apply them to population. Because basically we are interested in population. We know everything about the sample from the data we collect. There is nothing hidden from the sample. But we are interested in entire population, and sample is only a small part of that. That's why the results are applied back to the population. And this process of taking sample from the population, taking data analysis and applying the results back to population is called statistical inference, which is the second type of statistical methods that we study. In fact, in this class we spend more time on statistical inference than descriptive statistics. Many times statistics also gets misused. In fact, there is a famous statement by a British parliamentarian. In British Parliament, people used to come and present a lot of data and try to infer something from that data, and most of the times incorrectly. They were trying to prove anything to everything using data to justify their point. So this gentleman got very disgusted with what was going on with people trying to misuse data. So in his words, statistics, in fact it is his definition of statistics: lies, damn lies, and statistics. In fact, as per this gentleman, statistics is the worst form of a lie. In fact, this data looks like it is ordinal data, so it increases as we go from lies, damn lies to statistics. To counter this, I give this example, like you have a knife, and a knife can be used for cutting fruits and vegetables, but this knife can also be used for killing someone. Now, if somebody gets killed, we cannot blame the knife for that, we blame the person who misused the knife. And statistics is like that. So if people are misusing statistics, it is not the fault of the discipline or the science of statistics, it is the fault of the people who misuse statistics. So we need to be careful all the time, because many times people do use, not only misuse statistics. Let's take one example, and let's say there are two companies. Somebody collected data and found that drink 1 is preferred by 66% of the people. You can think of like Pepsi and Coca-Cola. And drink 2 was preferred by 34% of the people. Now, before jumping to conclusion that drink 1 is very popular or more popular than drink 2, we have to ask some questions related to statistics. So we need to confirm what we see here with some questions before we really do any conclusion or jump to any conclusion. One question is the sample size. One may ask, like, how much sample size was used for this survey or this data collection effort? And if you get an answer that in the university only 3 people were asked and 2 of them said they like drink 1, so obviously now you know that this is not a reliable data. So these numbers are not reliable because you have an extremely small sample and it is not a representative sample which can represent the population of interest. So obviously these results should not be relied on. We cannot draw any conclusion based on sample of size 3. So this way, I would say we have to be very careful when we look at any data and make sure that you draw proper conclusions, understanding the background before jumping into conclusion.